I welcome you all to my next session in organic chemistry. In this session, I am going to take up for discussion how to answer a very important type of question that you get in your organic chemistry paper. Look at the board. How would you chemically distinguish between the following pairs of compounds? You come across such question in almost every organic examination. Now in this example that I have taken, I have selected 5 pairs. You notice that the first 2 pairs have different functional groups and the last 3 have same functional group. Now when I take up the first one for discussion, ethanol and ethanoic acid. You all know that you will choose a test for which one gives a positive answer, the other one gives a negative answer. But you should also remember that your test must be such a one which is very quick. That is, it should be taking place within a few minutes or a very short time. And there must be some noticeable change like formation of a precipitate, effervescence or release of a gas, a color change, any characteristic smell emanating, separation of oily layer or something like that. So it should be commonly one of the things that I mentioned which should be observed in the test tube. One more thing, whenever there is an acid involved in the given pairs, it is the best or easiest test would be reaction of acid with sodium bicarbonate. You know, it immediately evolves CO2 gas, which is noticed as effervescence. Whenever an acid is given with any other functional group, choose this test, which will be answered positively by the acid and not by the other one. Now I'll tell you how to write a good answer for this. It's not enough if you know what to write. Presentation of the answer is very important because in the answer papers that I have come across when I corrected the board examination papers, students simply write bicarbonate test. The answer will be simply bicarbonate test. That is not the way to write. Or some students write ethanoic answers bicarbonate test. Ethanol does not give. That is not the way. You know, you are going to be given the two substances in two different test tubes labeled and A and B. Which one is the ethanol, which one is this ethanoic acid? That is what we are going to find out, and that is how you have to present the answer. Now you see on the board a very good way of presenting an answer for such a question. When you write like this, first of all you will be clear about what you are writing, and it will be very appealing to the person who is correcting the answer also. You can also write it as a paragraph answer where you have to state clearly that the two compounds are taken in two test tubes labeled A and B. To each test tube, a few drops of sodium bicarbonate solution is added. The one in which effervescence is noticed is the acid. The other one is the alcohol. You can write like that also, but this is one of the easy and good ways of presenting the answer because you are used to writing like this in your practical record also. The chemistry behind the test is the acid reacts with the bicarbonate solution to give the salt and releasing CO2 gas. Remember, when the acid is liquid, you can add a pinch of sodium bicarbonate, and when the acid is solid like benzoic acid, you have to add a solution of sodium bicarbonate. The equation is not necessary in all answers. This is only for your clarity I am giving you here. It's enough if you write explain the test and the observation. The second pair has propanal and propanone. Propanal is an aldehyde and propanone is a ketone. The two most common and important tests to distinguish between an aldehyde and a ketone are the tolerance test and the Fleming's test. For the tolerance test, you use tolerance reagent, which is ammonical silver nitrate. The other one is Fleming's test. And Fleming's test has Fleming's reagent, which is a mixture of two solutions. One is copper sulfate solution, the other one is sodium potassium tartrate. I am not going into the details of that now. Now, how to perform the test? You take the two organic compounds in two test tubes labeled A and B. So, take the two compounds in test tubes A and B. Now, to test tube A, when you add tolerance reagent and heat it in a water bath, what do you observe? You must be familiar with that. You must have done it in the laboratory also. Heated in a water bath, you get a shiny silver mirror deposited on the sides of the test tube. So, this shows the presence of silver mirror is no test. This shows the presence of aldehyde. Shows the presence of aldehyde. Here it is propanol. So we can say shows the presence of propanol. And the other one, test tube B, write in the same way, tolerance reagent, heated in water bath, no reaction. Presence of propanone. Is that clear? So this is another way of writing a good answer for such a test. So this is how you write a chemical test. You describe a chemical test that you perform to distinguish between the two given organic compounds. The next reagent is Fleming's solution. And for Fleming's solution, you mix Fleming's A and B. As I said, it is a solution of copper sulfate and sodium potassium tartrate. When you prepare the reagent and add a few drops of the reagent to test tube A and also to test tube B separately and heat the test tubes, you find that an aldehyde gives you a reddish brown precipitate and a ketone shows no such reaction. So you will have to write it in the same way. Test tube A plus Fleming's solution heated. A reddish brown precipitate obtained shows the presence of propanol. Test tube B plus Fleming's reagent heated, no reaction, shows the presence of ketone. So for the two pairs, I have given you the answers in two different ways. Whichever you like, you can write in the same way, but you cannot be more brief than what I have explained. The third pair has methanol and ethanol. Both are primary alcohols. So we cannot perform any of the characteristic reactions of alcohols. We have to choose a test in which only one of the two answers positively. Here we will use the information that ethanol is the only primary alcohol which gives positive answer for iodoform test. And what is iodoform test? It is the formation of iodoform CHI3 when you use the organic compound with the reagent iodine and alkali. Reagent is iodine solution, iodine in Ki. because iodine does not dissolve in water. It should be dissolved only in potassium iodide. Iodine solution and alkali is sodium hydroxide. You take the organic compound, say 1 ml of that, and add 1 or 2 ml of the iodine solution, followed by sodium hydroxide in drops till the dark color of iodine disappears. Heat the test tube in a water bath. The separation of a yellow solid is to be considered as a positive answer, and that will indicate the presence of ethanol here. I have done a separate session on iodoform reaction in which I have explained in detail about the compounds, different compounds which can be identified using iodoform test, and also the chemistry behind the reactions. So now we will see how to write the correct answer for this particular question. You can see the answer I have given. This is a detailed one. You can choose to write either this way or in a paragraph, but there should be clarity in your answer. In the fourth pair, you are given methanoic acid and ethanoic acid. Both are carboxylic acids. So which test shall we perform so that only one of the two gives a positive answer and the other one does not? Let us write the structure and see whether anything comes to our mind. This is methanoic acid and this is the structure of ethanoic acid. Look at the structures and see if you can find out anything. Any clue do you get from the structures? What is this group? This is an aldehyde group, isn't it? It is present in methanoic acid but not present in ethanoic acid. You don't have an aldehyde group here. In fact, methanoic acid is the only carboxylic acid having an aldehyde group. So keep this in mind. We can perform this test which I am going to explain, which is a reaction of an aldehyde when you are given methanoic acid with any other carboxylic acid for this type of a question. This reacts with Tollens reagent and gives the silver mirror, which is the typical test of aldehyde group. So the test that we are going to perform is with Tollens reagent. Reagent is ammonical silver nitrate. And you will write the answer as I showed in one of the earlier examples, that test tube A plus Tollens reagent heated in a water bath. Appearance of a shiny silver mirror shows the presence of methanoic acid. Test tube B, Tollens reagent heated in a water bath, no reaction, shows the presence of ethanoic acid. Is that clear to you? The fifth pair consists of acetic acid and oxalic acid. Acetic acid, you know, is ethanoic acid, and oxalic acid is a dicarboxylic acid, COOH, COOH. One is a monocarboxylic acid, the other one is a dicarboxylic acid. But both react in the same way when you perform tests that are characteristic of carboxylic acids. So, which test shall we choose now to distinguish one from the other? I'll give you one clue here. You are more familiar with oxalic acid than acetic acid in the laboratory. Can you think of the experiments involving oxalic acid that you perform in the laboratory? Yes. Some of you might have come a little close to the answer, no? You are doing redox titrations with oxalic acid. You use oxalic acid against potassium permanganate in the burette. In the presence of dilute sulfuric acid, you are performing the redox reaction between the two. Here, oxalic acid acts as a reducing agent and it reduces acidified potassium permanganate, that means it decolorizes. So write the reagent now. Reagent is acidified KMnO4. So we will write the answer as acidified KMnO4 plus a few drops from test tube A. What would be the reaction? Acetic acid is not going to give you any reaction, so we can write no change, or no decolorization also you can write. Shows presence of ethanoic acid. Now acidified KMnO4 plus a few drops from test tube B. Purple color is discharged. Purple color of permanganate is discharged. It becomes colorless. So shows the presence of oxalic acid. In fact, this is not a typical organic reaction, but we can use it here to distinguish between ethanoic acid and oxalic acid. So with these 5 examples, I suppose I have given you an idea of how to perform a test, and not only that, how to write a good answer. That is more important. Some of you might be thinking that it's a very simple question, but often students do not come out with a good answer when they write it on the paper. Hence, I insist that you write a very good answer which will be very clear to the person who corrects your answer. Choose the test with all the things in mind that I told you in the beginning, that it should be a simple one and the change must be noticeable. Thank you.